Imagine you're racing a car moving at 20 meters per second. Can you predict exactly where it will be after 5 seconds? Sounds simple? Think again. I'll show you how to master one of the most important topics in physics, motion in a straight line, using real-life logic and smart tricks. Let's go! Hello viewers. Welcome to the YouTube channel. In this video we will discuss Class 11 or First PUC Physics Chapter 2, that is motion in a straight line. Class 1. From basic to advanced level, for board, JEE, CET, and NET. Do support watch till end, don't forget to share, subscribe the channel. First chapter, that is units and measurement. That video link is given in description, don't miss it. Motion in a straight line. Mechanics. Mechanics is the oldest and fundamental branch of physics, and it is the study of the state of rest as well as the state of motion of object under the action of force. The study of mechanics is broadly classified into 1. Statics. 2. Dynamics. Statics. It deals with bodies at rest under the action of system of force. Dynamics. It deals with motion of a body under the action of force. Dynamics is again divided into A. Kinematics. B. Kinetics. Kinematics. It deals with the description of motion without reference to the cause of motion. Here mass of object is an important consideration. Kinetics. It deals with what moves and what causes motion. Here mass of object is not taken into consideration. Some of the terms used in describing motion are given below. Particle. A particle is ideally just a piece or quantity of matter, having no linear dimensions but only position and mass. Motion. Motion is change in position of an object with time. A car moving on a road, a runner doing laps, and the to and fro movement of swings are all examples of motion. Yet all these movements are of different types. So, depending on the path followed by the moving object, motion can be classified into rectilinear motion, motion in a straight line or linear motion, rotational motion, motion along a circular path, vibration motion, vibration of a body along a fixed axis, oscillation motion, to and fro motion of a body. In this topic we study rectilinear motion. Motion of objects along a straight line. Example 1. A car moving along a straight road. 2. A freely falling body. Mathematically, the motion is described in terms of displacement, distance, velocity, speed, acceleration, and time. Next. Event. An event is a physical process that occurs at a point in space and at an instant of time. Observer. A person or equipment which can locate, record, measure and interpret an event is called an observer. Let's take an example to understand. Consider a car moving towards the left with velocity 10 meters per second. There is person named A in the car and another person standing on the road named B. Now if we observe the motion of car with respect to observer A, he will say that car is at rest, so its velocity is 0 meters per second. On the other hand, if we observe the motion of car with respect to observer B, he will say that car is moving towards left with velocity 10 meters per second. Therefore we can say that the same motion can have different interpretations with respect to different observers. So in kinematics all the calculations are done with respect to the given observer. Frame of reference. It is the reference in which an observer sits and makes the observations. In order to specify the position, we need to use a reference point and set of axes. The choice of set of axes in a frame of reference depends on the situation. Next, rest. A body is said to be at rest when it does not changes its position with time. Path length. It is the actual distance covered by a body in time. It is also called as distance traveled. Example. Consider A to B. A car started from A towards B. Therefore, distance of car is ab. For example, in the figure, car is traveling from point A to point B and from B to C, then C to A. So we can say that the total distance traveled by car is distance A plus distance BC plus distance CA. That is 4 km plus 3 km plus 5 km is equal to 12 km. Note: path length is a scalar quantity. SI unit of path length is meter. Dimensions EM0, L, T0. Path length depends on the actual path. Path length is always positive. Displacement, denoted by S. It is the shortest distance between the initial point and final point along direction. It is vector quantity. SI unit of path length is meter. Dimensions EM0, L, T0. Displacement may be positive, negative and zero. Magnitude of the displacement can never be greater than path length. When a body moves in straight line, displacement is equal to path length. It is independent of the actual path traveled and is denoted by delta x. Example 1. If a car started from A and ends at C. Here A is initial position and C is final position. If I ask, the total distance traveled by this car is. Now you will tell 4 plus 3, that is 7 km. But in displacement is shortest distance between the initial point and final point along direction. To find displacement, we use Pythagoras theorem. That is, AC square is equal to AB square plus BC square. Substitute values, we get AC square is equal to 4 square plus 3 square. We get AC square is equal to 16 plus 9. That is equal to 25. On taking square root, AC is equal to 5 km. Therefore, shortest distance between final and initial position is 5 km. Example 2. If a car started from A and ends at A. Here A is initial position and A is final position. Here, if I ask, the total distance traveled by this car is. Now you will tell 4 plus 3 plus 5, that is 12 km. But, in this case, when we talk about displacement becomes 0. Let's see why. From definition, displacement is equal to final position, initial position. In this case, initial position is A. And final position is also A. Therefore, displacement is equal to A minus A. That is equal to 0. Next, difference between path length and displacement. Path length and displacement. Path difference. It is the actual distance covered by a body in time, t. It is also called as distance traveled. Displacement. It is the shortest distance between the initial point and final point. Path length is a scalar quantity. Displacement. It is vector quantity. Path length is always positive. Displacement may be positive, negative and zero. Path length is always greater than or equal to displacement. Displacement is always less than or equal to path length. Next, we see speed. Speed is defined as rate of change of position of a particle any direction. Formula is speed is equal to path length or distance by time taken. That is x by t. Speed is a scalar quantity. It is always positive. Its SI unit is meter per second. Dimensions m0, L0, t-1. Speed gives no indication about the direction of motion of the particle. Example. Calculate the speed of car if it travels 100 kilometers in 4 hours. Formula is speed is equal to distance by time. Distance is 100 kilometer and time is 4 hours. Therefore, distance is equal to 100 by 4. That is equal to 25 km per hour. Next, average speed. The average speed of a particle in motion is defined as the ratio of the total path length to the total time taken. Formula is average speed is equal to total distance or total path length by total time taken. Next, instantaneous speed. It is defined as the limit of average speed as the time interval is infinitesimally small. Next, velocity. Velocity is defined as the rate of change of displacement of a body. Formula. Velocity is equal to displacement by time. That is, v is equal to x to minus x1 by t. Velocity is a vector quantity. SI unit is meter per second. Dimensions is m0, L0, t to the power minus 1. Velocity may be positive, negative or zero. Average velocity. The average velocity of a particle in motion is defined as the ratio of total displacement to the total time taken. Formula. Average velocity is equal to total displacement by total time. That is, v dash is equal to x to minus x1 by t to minus t1. In generally written as v dash is equal to delta x by delta t. In the next class we study from acceleration. Don't forget to share, comment, and subscribe for more updates.